the quotient rule. We have a function, f of x, which is f of x over g of x. So we have a function. To find the derivative, we could go to the definition. Limit h approaches 0, f of x plus h minus f of x all over h. But you might have noticed when you find derivatives of quotients using the definition, it's a little intense. So what we're going to do is let's eliminate the fraction by multiplying everything by g of x. That allows us to work with an expression or an equation that doesn't have a fraction anymore. So we've got f of x times g of x equals little f of x. And the nice thing about that is now we just do a product rule. How marvelous is that? So this is our first term and this is our second. The derivative rule says derivative of first times second plus first derivative of second. Now if we've taken the derivative of the left-hand side, to keep the equation in balance, we take the derivative of the right-hand side. And that's where f prime x came from. So let's just look at that again. We had a fraction. We said let's eliminate the fraction so we don't have to work with it. And then we can use the product rule because we already know the product rule. Derivative of first times second, first derivative of second. If we took the derivative of the left side of the equation, it would balance with the derivative of the right side of the equation. Now, what were we trying to do here? We're finding the derivative of f of x. So that is this term right here. So this is what we're trying to get by itself. So to get that by itself, what if we start by taking this term to the other side? And then divide by g of x. Okay. So what we did again, our goal was to get f prime x by itself because we're finding the derivative of f of x. We took this term to the other side and then divided by g of x. Now, why is this highlighted? If you're finding the derivative of little f of x over g of x, you really want the expression in terms of little f and little g and not big f at all. So what can we replace big f of x with? F of x over g of x? Okay, and it's a messy again. So what did we do last time to get rid of that g of x? We multiplied everything by g of x so that we could eliminate this. So we're going to have to multiply g of x by the first term, g of x by this one, which will get rid of that, and g of x times this one. When you're done, what you get, f prime g, f of x g prime, because those get eliminated when you do the multiplication. And in the bottom, you would have g of x times g of x. So g of x times g of x is g of x squared, which can be simplified or abbreviated to g squared x. They mean the same thing. You might have seen that notation before if you think of taking sine of x squared. You don't tend to write it that way. You tend to write it as sine squared x. So it's the same thing. Why do we prefer this notation? There's a fewer brackets involved. Okay, so what have we done? We've said if we start with this as our function, this is our derivative. So that's what matters from today. If that's your function, that's your derivative. Okay, let's try it in action. We're finding the derivative. So the top function is x plus 1. The bottom function is x minus 2. We take derivative of top, so that would be 1, times bottom, x minus 2, minus top, x plus 1, derivative of bottom, that would be 1, over bottom squared. We can check it again to make sure we understand what's happening. There's our top. We're going to have the derivative of the top here and the original function there. Derivative of top here, original function. This is our bottom function, so bottom function. Bottom function appears here, and derivative of bottom function appears there, and bottom function squared. So that's where all your terms came from. Now, When we did the product rule, we said if it's messy, don't bother expanding this one, but this one, this is worth expanding. You almost always get to simplify things really nicely. So keep in mind it's a minus 1 times all those. So we'd have x minus 2 minus x minus 1. Leave the bottom factored. So how do you know when to expand and when to factor? So here's the trick. If you have a plus or minus sign between terms, you're going to be able to eliminate some things and put some stuff together. If there's nothing else down here, it is a complete and utter waste of your time to expand that. Just makes it messy. There's not going to be any terms to collect and put with them. So if you have terms separated by plus or minus signs, I'm expecting you to expand and collect terms. If you just have an expression to an exponent, leave it alone. All right, what did we have here? Minus 3 over x minus 2 squared. And why you want to simplify. Imagine we were doing this question, and you then had to take the derivative of the derivative. You'd much rather do that with this expression than you would this one. So that is why it's worth your while to simplify. And if you're thinking, are we really going to do that? Oh, yes. So let's do another one. There's our rule again. Derivative of top times bottom minus top derivative bottom, bottom squared. Let's see if we can do this. Derivative of top would be x squared times the bottom, x squared minus 2, minus top derivative of bottom, which is 2x, all over bottom squared. Let's check that we understand where everything came from. Top function, derivative of top, top function. There's our top function, there's the derivative of the top, and there's the top function. Bottom function appears here, derivative appears there, bottom function squared. So there's our bottom function, it appears here. There's the derivative of the bottom function, and there's the bottom function squared. Okay, let's keep going. We know we want to simplify that. It's going to be much easier later on if we're good at this. So 2x cubed minus 4x. This one, some people find it easier instead of putting the 2x here to put it out front with the minus sign. They can see more quickly what they're doing when they expand, so feel free to do that. We get minus 2x cubed minus 6x. Leave the bottom alone. Oh, look at that. Those are going to eliminate, and even better, these are going to collect. So we get minus 10x over x squared minus 2 squared. Now, if you're looking at this question and saying, whew, how do I memorize this derivative rule? You might notice that the top looks an awful lot like the product rule, except it's a minus sign. So if you've learned the product rule, it should be fairly quick to remember this part, and then just put it over to the denominator squared. Okay, let's have some fun. We're going to take the derivative of this function. It is a quotient. But when it comes time to taking the derivative of the top, this is a product rule. Holy moly. So we're combining the quotient rule and the product rule. So I'm going to try and keep you organized. The function, when you're looking at a quotient, we have a top and a bottom. The derivative rule, derivative of top times bottom minus top, derivative bottom over bottom squared. In this case, our top function is one function times another. So I'm going to write that as first times second. And when you have a product rule, its derivative is derivative of first times second plus first times derivative of second. So our little cheat sheet over here now looks like this. And why I'm writing this down. When you get into complicated derivatives, it's really easy to get confused and forget where you are. So we're going to look at this and see if we can do the question. Here we go. Derivative of first. 2x plus 7 times second. Write down x squared plus 3x plus 4. Plus first, x squared plus 7x minus 1. Derivative of second. 2x plus 3. Maybe I should write it down here. and then we'll write it nicely later on. So what did we say? Derivative of first was 2x plus 7. Back up, multiplied by the second term, x squared plus 3x plus 4. So that's derivative of first times second plus first, x squared plus 7x minus 1. Derivative of second, 2x plus 3. And where are we? We're right here now. We have to multiply this entire thing by the bottom function. And then keep going with the quotient rule. Minus first times second times derivative of bottom. Whew. Okay, so there's first, second, derivative of bottom. Put the whole thing over the bottom squared. So there's a lot more to this than what I can actually fit on the screen over here. And that's why I tend to write these down, just to remind myself what on earth I'm doing. So let's see if we can follow what we did. Let's get a highlighter out for us. Okay. Derivative of first. Okay, that's not such a smart idea. Derivative of first. And this is our first. So derivative of first went here, first term went there, first term that went there. All right. Second term is this one. So it appears here. Derivative of the second term, that's where that came from. And second term again appears here. Okay, what's the rest of it? The rest of it comes from the bottom. So the bottom is this term. So that's where that came from. Derivative of bottom, that's the 8x, and bottom squared. Ooh, so you have to be very careful when we're starting to mix up product rules with quotient rules. And I find it helps me to write this. And how I would use it, I would just have it on the side, and as I did anything, I'd check it off. Derivative of first, second, plus first, derivative of second, remind myself I need to keep going and do all the other steps. And that keeps me organized, and then I tend to get the right answer. Would I expect you to multiply that out? Not at the moment. Okay, your job today, don't panic, they don't look like this. Doing A to L. Let's get this in your brain so that rule gets memorized as well. Have fun.